Assalamualaikum and good day. I wish to our lecturer Dr. Maman Hamanah. Today we are from group 3 and we will be presenting the title of AVO analysis. And now I will pass on to Roshan for introduction and theory part.
Thank you, Galef. My name is Roshan, and I will start with the introduction of AVO analysis. AVO is actually the short form of amplitude versus offset. AVO is a geophysics technique which is used to analyze the seismic data. It is mainly used in petroleum explorations. They use AVO to actually find the size and shape, and also decide how to plan the drilling and production operations of the field, of the oil fields. Now I'll be talking about the theory of AVO analysis. Okay, so the theory of AVO analysis is the principle that the amplitude of seismic wave changes with the angle of incident and the properties of rock. The reflection of a seismic wave from a subsurface rock layer depends on an acoustic impedance contrast between two layers. When a seismic wave passes through a rock layer, some of the energy is reflected back to the surface. This energy which reflected back to the surface, they depend on the impedance contrast. Next, I'll be passing on to Khalif to continue the methodology of this AVO analysis.
Thank you, Mr. Roshan. Now we'll be presenting about the methods part or the methodology of our projects. For the first method is calculating the AVO volume, which is calculating the AVO volume attribute and display the attribute of the product, which is the Poisson ratio. And then the AVO graph generation, where we will be generating an amplitude versus offset graph or intercept A and versus gradient B graph, which we will be generating the graph on the GeoView software. And lastly, determining the AVO class. Determining the AVO class of each, we will be determining the AVO class of each reflector based on its position relative to the expected trend. And now I will pass on to Namalan for the result, discussion and the conclusion part.
Now moving on to the results section. This analysis was done using the ASCII research realization of the Zuckerberg AVO equation. There we use the A, B, and C. What are these A, B, and C? A stands for the intercept, B for the gradient, and also C for the curvature. Primarily, then after using it, we will be plotting it into the intercept versus gradient plot graph as shown in the figure. So what is the intercept, gradient, and AVO? The intercept is the zero offset of normal incident reflection amplitude and of an event, while the gradient is the change of reflection amplitude with the offset of incident. As you can see in the right hand side of these slides, there is the relationship between the reflection coefficient versus the angle of incidence at a certain event, and this is then computed to the intercept and gradient format as shown in the result section here. So every section of that particular plot, which is the intercept gradient plot, we can deduce where is the data points are set, and using the figure on your most right, we can distinguish the type of AVO classes. So what are these AVO classes? So to answer that question, AVO classes indicates There are four different types of AVO classes. Class 1 indicates a positive correlation between the amplitude of the reflected wave and the angle of incidence. This usually observed in rocks with low porosity and low fluid saturation, mainly like shale and also claystones. Uh, Class 2 indicates the negative correlation between the amplitude of the reflected wave and the angle of incidence. This is usually observed in the rocks with high porosity and high fluid saturation, like the sandstone. And class 3 indicates a complex AVO response which may be caused by factors such as the thin layers or also the gas-bearing sand. Meanwhile, class 4 indicates a gas-bearing reservoir with low saturation and clean sandstone that is not heavily saturated with hydrocarbons. However, the AVO classes is not always a definite indicator of presence or absence of hydrocarbon. There are other factors that should be considered. These parameters, however, can be used to estimate the physical properties of rock and fluids such as the porosity, saturation, and also the fluid type. It wouldn't be 100%, but it's a prediction. So to conclude, the AVO analysis is a theoretical technique for estimating the physical properties of subsurface rock and its fluids based on seismic data alone. AVO analysis helps to determine key parameters such as the A and B, which provides a valuable insight into the lithology properties, the fluid types and the fluid properties, and also the overall reservoir properties in terms of the mineralogy and so forth. The AVO classes also provides a useful framework for understanding the relationship between amplitude and offset, which is then as well as the physical properties of subsurface rocks and also the fluid. So how does this help in the exploration process? AVO analysis plays a crucial role, by the way, in the reservoir characterization and exploration, and is an essential tool for geophysicists in the oil and gas industry. So, we would like to be a part in the continued advancement in seismic technology, and data analysis techniques are likely to keep AVO analysis an important area of research and development in the field of geophysics, making it more accurate and also more reliable. So with that, I would like to end our presentation on the AVO analysis. So thank you.